main tests for this to measure the reliability. What we perform is TZDB and TDDB. TZDB is the most common dielectric breakdown test. It's where we apply an initial voltage, ramp that voltage up, and monitor the leakage current. When the leakage current increases exponentially, we know we have breakdown. TDDB is supplying a constant voltage to the dielectric, and again monitoring the leakage current. And when that leakage current increases exponentially, we have dielectric breakdown. The reason this is important is because the dielectrics we're measuring will be the foundation of the integrated circuits that TI will be putting into different products. So to measure the reliability of these dielectrics is to measure the reliability of the various products that TI is putting out into the market. So they want it to be as reliable as possible. Now I'm sure you're wondering that there's already items on the market that can measure reliability of dielectrics, that can measure the dielectric breakdown. These are parameter analyzers. The problem with these, there's three main problems with this. One, they cost about $100,000, which is more than we can afford. Two, they use these little probes that you have to put on the dielectric with a microscope, and these things they can move. If a fly lands on the parameter analyzer, these probes, they'll move out the dielectric and you just lost all the data. Three, you can only measure one dielectric at a time with these parameter analyzers, so none of these are desirable characteristics of a parameter analyzer. Now, what our solution to this is, we have created a fairly inexpensive circuit which can measure multiple devices in parallel, once scaled up. And we do this in three parts. There's a voltage booster, which we can supply a voltage from 1 to 5 volts, boost it all the way to 200 volts, up to 200 volts. Then this is supplied to the dielectric, and then we have a ammeter which we've constructed using various few op amps, which are fairly inexpensive. And this ammeter can measure accurately down to the picoammeter range. And this interfaces to a microcontroller, an Arduino microcontroller, which will take all the data and monitor the leakage current. Once that leakage current increases exponentially, it'll collect the data, recognize the breakdown, collect all the data for us to analyze later in the year. Once we gather all this data, we're going to look at all of it, and we're going to pop it in Excel and get a lot of graphs, model the reliability of these dielectrics, and then talk to TI about our results. Now, me and Jake worked on interfacing our PCB to the Arduino microcontroller. Balaram Kuch worked on the ammeter, and Gaurav Pearl worked on the voltage booster circuit. Questions? Yes?
So you worked for a TI project and you ended up with an Arduino microcontroller. How did you complete your choice?
Well, the Arduino, since none of us have experience with microcontrollers, we find more examples and help on the internet with Arduino as opposed to
And another thing is easy to interface using a lab view with Arduino. Then I have no idea how to interface.
So your boost converter, you obviously got it wrong with the simple switch. What are you using for a controller for your boost circuit?
We're actually using the inductor and transistor switch. So we're using BZT transistor for now. We're going to switch it to MOSFET. And we're using a false signal to switch it on and off rapidly, so we can increase the voltage across the capacitor here. And there is a diode connected in parallel to that capacitor. That's a zero diode, and that is going to limit the voltage in the capacitor. So we can control it, and we can control it using the duty cycle of the pulse we're sending and the frequency of the microcontroller.
Okay, and how accurate is that 200 volts, or any voltage in between each bit?
It's fairly accurate. It's we had to generate like 200 volts. It was very inaccurate volts.
But what is your requirement? What is your accuracy requirement?
The dielectric breaks down somewhere around like 150 to 200 volts. So we just had to do like plus minus 5%.
Okay.
Why is this information of use to the DLP group at TI?
Well, as I mentioned, these dielectrics, we don't know too much about this, and we can't talk about too much because of proprietary information. from what we understand, this will be an integral part of the integrated circuits that these devices will be in. So if these dielectrics break down, well, to understand the reliability of these dielectrics will be to understand the reliability of the integrated circuits